Hi, in this part we'll look at programming the GAL chips, GAL 1 and GAL 2 for the 68 KB board. For programming the GAL chips we use the WinCouple Atmel software, which is pretty simple and basic program. Sometimes it's a little bit buggy, but it does the job. So let's look at the GAL 1 chip to program, and it's basically to do with decoding the address lines for the chip selects for the RAM and the UART. So if you have a look on the actual schematic diagram, the chip selects go to the UART, the RAM. There's a DTAC signal that's got to go out, there's a ROM signal that's got to go out, and there's also a chip select for the 6850, but we're not using it at this point. If you remember in my previous videos, LDS line is missing in this GAL input, so that is connected to pin 18 from pin 3 of the GAL 2 chip. So this line here goes to pin 18. And all these other lines that you see, like AS, read write, ignore this one for the time being. RMM is also ignored, and the address lines here are the input lines to the GAL chip, and these are basically the output lines that go out. So now if we look at the program, basically there's a introductory information here. What's important is this last line, which is the G22V10 specification for the device, telling it's a 22 pin chip with 10 inputs, and rest of the pins are either input or output. The first thing you do is basically define all the inputs. So if you look at, for example, pin 1 is the negative AS line, so that's the reason why I labeled it like NAS, and so on. You've got the read write and so on. You go down the line and put all these address lines and all the other signals corresponding to the pinouts of the GAL 1 chip. Now for the outputs, you define all these. In our case, if you can see the little bar that's across the actual letters, it means it's going to be negative on the output. So this exclamation mark here means it will put out a signal there, but it's active in the negative state. The same for the chip select RAM and DTAC, and ROM is not being negated, it's just a normal signal, and similarly for the 6850. Like I said, we're not doing anything with this one, so just ignore that one. Now, one of the things you do is you define sort of address lines from 812 to 23. We're not decoding the full set of lines. What is important is basically only a few of the lines in the actual memory map. And how you define it is by this equation, sort of equation here. And this first part here is for the ROM part of the NVRam, and it's basically saying from 0 to 3 FFF address lines is the ROM area, and it's active when we're only reading it, and when it's not address stable signal active. So when all these are 1, like that's 1 and that is 1 and that is 1, it should be able to read the ROM in this address space. And then we're saying it's also enabled if we read anything from 4000 to say BFFF, and it's active address signal. And then for the chip select for the UART, it's actually from address C001 or any space between this and CFFF, and it's the low data lines. So that's the reason why we're using this NLDS, which does come from that pin 3, or actually pin 18 that you see on here. and then you just redefine the actual outputs as being equal to these equations, and then you can see if they're all 1, the output will be negative when it's active. Now this ROM thing is just basically rerouting the A19 address to the input of the RAM, because we're not actually using it as a ROM switch at this point. So all I'm doing is rerouting the A19 inputs, which should be pin 9, and it's going to the ROM output, so it's basically going from here to there, and then that goes to pin 1 of the memory chips and provides this address. That's basically it for the GAL 1. So what you do now is you compile the code. Compilers, yes, and let's try it again. Something not happening here. Okay, it's compiled okay. I sort of lost this window, so that's the reason for the delay. And if you click OK, you see it produces a number of other output files, and one of them is the JED file. That's the one you use to program the actual GAL chip. This one here is the sort of all the equations and the pinouts and the output logic and whatever, and also puts out the labeling of all the pins for the chip. So if I go to the actual layout of the chip on the schematic diagram, you see they should correspond, like NAS should be that one there, RMM should be there, and so on. So they should be exactly the same. So that's basically it. Now you can use the programmer of whatever kind you have to program the GAL 22V10 chips. Okay, now we look at the GAL 2 chip programming. Similar sort of thing, you just got to make sure that it's correct device in the specification of the PLD program. I'll get back to the schematic diagram so you can see the correspondence. So GAL 2 chip is this one here, and basically in this one all you want to do is provide the separate read and write signals for the upper and lower RAM. So that's the reason why you got the read-write signal in, LDS and UDS coming in, and then getting all these two signals out for lower and upper read and write. You can also just invert these from negative to positives, and that's what these two pins are. And later on we can use the 3.6 MHz clock crystal divided by 2, and then put it out as 1.8 MHz that you can feed it in the 6850 UART. So let's look at the code here. The inputs are the clock, the read writes, NLDS and NUDS, and then the outputs are defined as negatives again, LWR, LRD and so on, and just the inverse of the LDS and UDS being in a positive state here. And the simple equations are written in this space here, where the lower right is whenever it's the lower data addressing signal, and it's the negative of the the negative of the right, which is negative inactive state, so it becomes 1. So 1 and 1 makes that active, and then it becomes negative to activate this pin here, and so on. So similar sort of thing for all these other equations, and these are just the negative of each other. And same sort of thing again. You compile the code, and it goes on the other screen. So I'll have to get it across, and you'll see the code say that it was okay, and you get the appropriate JD file and similar sort of document file that you can look at. Gives you all the equations, the pinouts, the actual coding, and the layout of the pins. And that's basically it for programming the 2 GAL chips. Hi, this is an example of how to program the GAL chips and the NVRam for some of the microprocessor boards. In this case, we're showing an example of programming the GAL and the NVRam for the 68K board, but it can be used for any of the other microprocessor boards. So to program the GAL chips, usually you insert them in Universal Programmer. The one I use is usually the GAL brand of programmers. If you look on the web, there is hundreds of Universal Programmers, and here's some pictures of the GAL type programmers that you might be able to get. They're not cheap, but they're reasonably good. So once you start the program, usually if everything's connected okay, it will say initiate and so on, and you've got a connection to the actual device, and as you can see, there's a light on the actual board saying that it's linked to the computer via the USB. So if you're going to program the GAL chip, you need to select the device from the devices list, and because I've already done this, I usually have like a short list of these, and the one I'm using is the Lattice GAL 22V10D, and it automatically puts all the information that you need, and just say OK, and you'll see here it tells you which manufacturer it is and device type, and usually the size of the PLD and how many pins and so forth. The next thing you need is the actual JED file, so we go and try to load the file that we need. So I'll just look for that particular one, and the one I'm going to use as an example is this one here, and just say OK, and it loads it in the memory of the program. And then you've got other options here, like erasing the chip before it starts programming it, and verifying and so on, or securing it so nobody else can read it. Usually I uncheck that. It might be different with your type of universal programmer. So then once everything is okay, all you got to do is just press program, and it should do all these steps like erase, then program, and then verify, and so forth. So let's go program, and as you can see, it's blinking, carrying on, it's erasing, programming, and it only took like 2.1 seconds. Some of the important things to check like this checksum here. So if you ever program something, you can always read it back and make sure that this checksum is the same for the chip that you just programmed. That way you know it should be okay. So if I read it back, it should come up with the same number, which is 4522. And if I read it, and there it is, it's come back with the same sort of number, so that should be okay. So you just take the device out and then you put it in your board and carry on. For the 68 KB you need 2 GAL chips, GAL 1 and GAL 2. I'm not going to show you the GAL 1 because I've already done one as an example. I'll show you now the NVRam, and for the NVRam you do the similar sort of thing. You've got to select the device. In this case we're using the 1250Y device, and just say OK. You can see the settings have changed, and that's the size of the chip, which is 512K by 8. And again, you insert the chip, make sure it goes in the proper way. I'll try to put it in, yep. And once it's in there, and then you again load a file that you want to program. In this case it's a binary file, so all I'll do is change the extensions, and I'll just program the lower 8-bit memory chip, which is this one here. Just say OK, and here you can change where you want to put the information. Do you start from 0 address, and where do you start from the file address, and so on. So this might be again different on your Universal Programmer program, and all these other settings and so forth. Or what do you do with the memory spaces that are left? You know, do you fill them with FF0 or disable or all that sort of stuff? So usually these are all default, so just click OK, and you can see it's loaded the file into the program memory, and you can re-edit. You can re-edit the. I'll just bring the screen for that here. You can see that it shows you the actual data that's loaded in the memory of the program, and at some point about 1500 it goes all blank. So all this data is for the lower byte memory chip, and you do a similar sort of thing for the upper byte one. Manually you can change any one of these, change the value of the actual byte for a particular memory address. In some cases that's rather good, because you don't have to recompile something if you know exactly which data bits or data bytes you want to change. Okay, so in this case, similar sort of thing. It's already the chips inside the programmer, and you just go program, and it will do a blank check. Well, it won't be blank in this case. Program verify. So let's see if I just tell it to program, see what happens. Program, yeah. So it's erased it, and well, I actually used the blank one. So and then programmed it, and you can see there is a checksum for the actual thing. So you can again read the thing just to make sure it's the same sort of number, and let's see what happens. And it's come back with the same number, so everything's fine. So that just shows you an example of using a universal type programmer and programming your GAL and NVRam type chips for any of the microprocessor boards that I give you as an example.